In part 1 of our series on check continuations, we'll return to our overly simple app and flirt a bit with async before introducing the familiar delegate pattern. Next time, we'll merge the two worlds. So in our app, there's a next button, and when you tap it, you get a random number between 1 and 50. Our view is very simple. We need to store the number somewhere, so we'll use a state property. As for the view itself, we'll define our body to contain a VStack, and on top will be an image that we create using this helper method that accepts an int and returns an image consisting of the SF symbol of the int surrounded by a circle. Below the image in the VStack is a button. The label of the button is next, and the action produces the next current value. To help with this, we have our view model or our controller that we'll call support. Support has a method named next, which will produce this next value. Tap the button, we get a new value. So let's take a look at support. The key is that it contains the next method, which returns an int, and for simplicity, let's return a random number between 1 and 50. Run the app, it works perfectly. The difficulty becomes if we add something that takes a while before we return this int, something that might require the async mechanism. Without async, this will block everything. When we tap the button, we synchronously call next, and we just wait. We freeze the entire UI. Well, that something that takes a while takes that while. If we're lucky and we've architected this well, perhaps we can extract that thing that takes a while into an asynchronous method. The fact that the method is async will allow us not to block. And so we'll call the thing that takes a while and mark it with await to indicate there's a potential suspension point. This means that thing that takes a while must be called from an asynchronous context, and so one solution is to mark next as async. If we do this, there are required changes to the button's action. For one, we have to mark support.next with await, as that's a potential suspension point. And then it must go in an asynchronous context, so in this case, let's wrap it with a task. In other words, support.next, and then assigning that to current value is the work of this task. Run the app and you'll note that this doesn't block. The reason is that support.next will happen off of the main thread. And so the thing that takes a while will execute on some background thread and return on perhaps another thread, and then next will return on perhaps another thread. And so at this point, we're still off the main thread, and we have the value of the int that's been returned, and now it assigns to current value back on the main thread, and we see the result. And that's the dream. Unfortunately, we all have existing code. And that existing code was created before there was async and await. And so in our existing code, we didn't have this asynchronous method. One of the solutions we had in the old days was delegates. And so if we want to use delegates in our current code, we have two choices. One is we can refactor the main view to use the delegate, but I'm going to show you choice 2, which is leave the main view as it is. And so our communication between the main view and support uses this asynchronous method next, and we'll wrap the delegate so that support, the next method, uses the delegate protocol, which has this method did return. And so next calls into the delegate user, calling the method chooseNext. This means that support must conform to the delegate protocol, so it must implement did return. And when support creates the instance of delegate user that it calls chooseNext on, it passes itself as the delegate. And this allows chooseNext to call its delegate, which is support, and call the did return method on it. This is the classic delegate pattern. So let's code up the individual pieces. Let's start with the delegate protocol itself. The delegate protocol has a single method in it called did return, which accepts an int. Next, let's code up the delegate user. The delegate user must have some place to hold the delegate once it's been set, and because it's a class, we need to create an init for it, which sets that delegate. And now in an extension, let's implement the method chooseNext. ChooseNext will select a random number between 1 and 50, and then there's something that takes a while, but we're not freezing our UI in any way because we call back the delegate if it exists, and call back the did return method and pass the number to it. No one's waiting for anything to come back from chooseNext. This is a classic way of doing asynchronous coding before we had async await. So what remains is to make support work. Support has our asynchronous method next, which returns an int, and so just to keep the compiler happy, I'm going to return 0 for now. Support must create its instance of delegate user and pass itself as the delegate, so this must be done lazily. And this won't compile because we don't conform to delegate protocol yet, so let's go ahead and do the conformance. To conform, we need to implement the method didReturn. And so now that we conform, in our next, we can call delegate user chooseNext, and at some point, chooseNext will call back didReturnNumber and pass the number, and for now, we're just going to print it. So to take a look at the flow, from main view, when we tap the button, we call this async method next in support. In turn, support calls chooseNext whenever it's ready to. Delegate user calls back its delegate, which is support, and calls back didReturnNumber. That's where we are at this point, and we know that it works because as we run the app and we tap the button, we see the number printed in the console. And now we leave you with a cliffhanger, because we haven't completed the loop. Next time, we'll add the piece where next returns the int to the main view, which allows it to be displayed in the GUI.